Hi, I'm Edsel Abril from Math 2A. Our topic for this is under the properties of matrix operation, which is the properties of matrix multiplication. Properties of matrix multiplication are associative property of matrix multiplication. For example, quantity A and B multiplied by C is equal to A multiplied by the quantity of B and C. Second is associative property of scalar multiplication, which for example is lowercase c multiplied by the quantity of A and B is equal to quantity of lowercase c and uppercase B quantity multiplied by B is and equal to A multiplied by the quantity of lowercase c and uppercase B. Next is the left distributive property. Example is C multiplied by the quantity of A plus B is equal to C multiplied by A plus C multiplied by B. For the last one is right distributive property. For example is A multiplied by the quantity of B plus C is equal to A plus B, AB plus AC. We get know all the properties of matrix multiplication through the following example. First, matrix multiplication is associative. For example, show quantity AB multiplied by C is equal to A multiplied by the quantity of B and C, which the value of matrix A is equal to 1, negative 2, 2, negative 1. The value of matrix B is 1, 0, 2, 3, negative 2, and 1. The value of matrix C is negative 1, 0, 3, 1, 2, 4. The rule in multiplication of matrix: if the number in column of matrix A have the same number of row in matrix B, you can perform the multiplication of matrix. For this example, we have 1, negative 2, 2, negative 1. Another matrix, example 1, 0, 2, 3, negative 2, 1. For this first matrix, we have a 2 by 2, 2 rows and 2 columns. For the second matrix, we have 2 by 3, 2 row, 3 column. It means they are the same number of column in first matrix and same number of row in second matrix. You can perform the multiplication or the matrix multiplication. To get what our final matrix order, when these two number, to get the, or we can know if we can perform the matrix multiplication, these two number, we can know what the order of our final matrix. If we multiply matrix 2 by 2 and 2 by 3, we get a matrix or final matrix of 2 by 3. For our example, multiply matrix A to matrix B, we have a 2 by 2 and 2 by 3. AB, for our previous example, AB, multiply C, which the matrix A is equal to 1, negative 2 to negative 1, matrix B is equal to 1, 0, 2, 3, negative 2, and 1. For matrix C is negative 1, 0, 3, 1, 2, 4. In multiplication of matrix, we multiply the first column and first row to the corresponding elements. 1 multiply 1 is equal to 1, where we get this 6. So we multiply to get our first element. We multiply this first row to this first column. First element, 1 multiplied by 1, and add the second one, negative 2 multiplied by 3 is equal to 6. We add these two. For the second element, we multiply first row to the second column. 1 times 0 is equal to 0. Negative 2 times 2 is equal to 4. So we add these two elements. For this third element, we multiply this first row to this third column. 1 times 2 is equal to 2, plus negative 2 multiplied by 1 is equal to negative 2. For the second row, we multiply this second row to first column. 2 multiplied by 1 is equal to 2. Negative 1 multiplied by 3 is equal to negative 3. For the second element, for the second row, second column, we multiply 2 to 0 is equal to 0. We multiply negative 1 to negative 2 is equal to 2. For this last element, we multiply this second row to this third column. We multiply 2 to 2 is equal to 4. We multiply negative 1 to 1 is equal to negative 1. So, and also copy the matrix of C. 1 plus negative 6 is equal to 5. 0 plus 4 is equal to 4. 2 plus negative 2 is equal to 0. 2 plus negative 3 is equal to 1. 0 plus 2 is equal to 2. 4 plus negative 1 is equal to 3. To our rule, when we multiply 2 by 2 and 2 by 3, we get a 2 by 3. We get a 2 by 3 matrix for this matrix. Since we have a 2 by 3 and 3 by 2 matrix, so we get a 2 by 2 matrix. To solve this one, as what we can do for this process, we can do it to this again. Negative 5 multiplied by negative 1 is equal to 5. Multiply this first row to this first column. Negative 4 multiplied by 3 is equal to 12. 0 multiplied by 2 is equal to 0. Negative 5 first row multiplied to the second column. Negative 5 is equal to 0. Multiplied by 0 equal to 0. Negative 5 multiplied by 1. Negative 4. 4 multiplied by 1 is equal to 4. 0 multiplied by 4 is equal to 0. For the second row, we multiply this second row to this first column. Negative 1 multiplied by negative 1 is 1. 2 multiplied by 3 is 6. 3 multiplied by 2 is 6. For the last element, we multiply the second row to the second column. Negative 1 multiplied by 0 is 0. 2 multiplied by 1 is 2. 3 multiplied by 4 is 12. So, we can add to get our final matrix. 5 plus 12 plus 0 is equal to 17. 0 plus 4 plus 0 is equal to 4. 1 plus 6 plus 6 is equal to 13. 0 plus 2 plus 12 is equal to 14. It's like what I said, for this 2 by 3 matrix, 2 by 3 matrix and 3 by 2 matrix, we get a 2 by 2 matrix. For the second, we get the value of matrix. We get the value of matrix A, quantity A, B multiplied by C. For this example, we can get the value of quantity A multiplied by the quantity of B and C. The value of A is 1, negative 2, 2, negative 1, 2. The value of matrix B, 10, 2, 3, negative 21. The value of matrix C, negative 1, 0, 3, 1, 2, and 4. So, first we get the value of quantity B and C. As like what the process we do for the previous example, we multiply these two matrix, the value of matrix B and the value of matrix C. We get 3, 8, negative 7, and 2. This copy the value of matrix A. Since we have these two matrix, we multiply again, just like the process to get what the value of matrix B and C. We get the value of matrix A, quantity B, C is equal to 17, 4, 13, and 14. We can say that quantity AB multiplied by C is equal to A quantity B and C, because the value of quantity AB multiplied by C is equal to 17, 4, 13, and 14. The quantity of the value of A quantity B and C is equal also as 17, 4, 13, 14. So we can say that quantity AB multiplied by C is equal to A multiplied by the quantity of B and C. For our next topic is commutativity of matrix multiplication. For the example is show that AB is not equal to BA. which the value of matrix A is 1, 3, 2, negative 1. The value of matrix B, 2, negative 1, 0, and 2. Just like what the rule in multiplication, if they are the same column, if they are the same, if the first matrix same in the column or row in the second matrix, we can proceed to the matrix multiplication. For this, another, just like what I said a while ago, two row and 2 column for the matrix A and B, we get a 2 by 2 final matrix for the final answer. Matrix A and B, since they are same order, we can multiply them, or same in matrix or column of matrix A and row in matrix B, we can multiply them. AB, which the value of matrix A is 1, 3, 2, negative 1. The value of matrix B is 2, negative 1, 0, and 2. We multiply this first row to this first column. 1 multiplied by 2, 3 multiplied by 0. 1. To get the second column in first row, we multiply 1 and 2, I mean 1 and negative 1, 3 and 2. For this second row, first column, we multiply 2, 0, 2, and negative 2 and 2, plus negative 1 and 0. For the last element, we multiply 2, negative 1, and we add the 1 multiply by 2. So 1 plus 2, 1 multiplied by 2 plus 3 multiplied by 0 is equal to 2. 1 multiplied by negative 1 plus 3 multiplied by 2 is equal to 5. 2 multiplied by 2 plus negative 1 multiplied by 0 is equal to 4. Negative 2 by 2 multiplied by negative 1 plus the value of negative 1 plus 2 is equal to negative 4. Since we have a 2 by 2 matrix, they are both 2 by 2, we get a 2 by 2 matrix in our final. These are the value of matrix A and B. Next, we getting the value of matrix B and A, and we can show it that is not equal or equal. Value of B matrix is 2, negative 1, 0, and 2. Value of matrix A, 1, 3, 2, negative 1. Same as the process in getting the value of AB matrix, we also use this to get the value of matrix B and A. 2 and 1 plus negative 1 plus, we multiply negative 1, 2. We multiply this first row to the second column. 2 multiplied by 3, negative 1 multiplied by negative 1. Second row to this first column, 0 multiplied by 1 plus 2 multiplied by 2. Second row to the second column, 0 multiplied by 3, 2 multiplied by negative 1. 2 multiplied by 1 is equal to 2 plus negative 1 multiplied by 2 is equal to 0. 2 multiplied by 3 is equal to 6 plus negative 1 multiplied by negative 1 is equal to 7. 0 multiplied by 1 plus 2 multiplied by 2 is equal to 4. 0 multiplied by 3 is equal to 0 plus 2 multiplied by negative 1 is equal to negative 2. We can say that the value of A and B, the value of matrix AB is not equal to the value of matrix BA, which the value of matrix AB is 2, 5, 4, negative 4. The value of matrix BA is 0, 7, 4, negative 2. We can say that matrix AB is not equal to matrix BA. Next is an example in which cancellation is not valid. Show that AC is equal to BC, which the value of matrix A is 1, 3, 0, 1. The value of matrix B 2, 4, 2, 3. The value of matrix C is 1, negative 2, negative 1, and 2. We can prove that AC is equal to BC. First, we get the value of AC. AC, just like the process. First column multiplied by first row multiplied by first column. For this one, first row multiplied by the second column. For this one, second column multiplied by first, second row multiplied by first column. For this one, second row multiplied by second column. We get a value of matrix AC negative 2, 4, negative 1, and 2. That's the value of matrix AC. What about the value of matrix BC? Matrix BC, the value of matrix B is 2, 4, 2, 3. The value of matrix C is 1, negative 2, negative 1, 2. To get what the value of our first row, first column, we multiply this first row to this first column. We get the value of 2, negative 1, 2 multiplied by 1 plus 4 multiplied by negative 1. First row to second column, we get the value of 4. Second row to first column, we get a value of negative 1. Second row to second column, we get a value of 2. That is the value of matrix BC. Matrix AC is negative 2, 4, negative 1, and 2. Matrix BC is negative 2, 4, negative 1, and 2. We can say that the matrix AC is equal to the matrix of BC. For another example, multiplication by a matrix identity. Just like the rule said, we can proceed to the multiplication of matrix if the matrix If the first matrix have the same in the row of second matrix, the first row of matrix and the second or the column of second matrix is 3 by 2 is the order of our final matrix. For example, matrix A is 3, negative 2, 4, 0, negative 1, and 1. 1, and another matrix is 1, 0, 0, and 1. Just like our process a while ago in multiplication of matrix, is the same here. We multiply this first row to first column. We multiply this first row to this second column for this one. For this one, we multiply second row to first column. For this, we multiply second row to second column. For our last row, we multiply third row to first column. We multiply third row to second column to get the final element. Three, negative 2, 4, and 0, negative 1, and 1 is a 3 by 2 matrix. We have a 3 row and 2 column. For our next example, repeated multiplication of a square matrix. For our first example is find a cube, which the value of a is 2, negative 1, and 3, 0. For the a cube, we get first the a squared and multiply the value of a to get the a cube. The value of a is 2, negative 1, 3, and 0. Since this is cube, we multiply 3 times, or multiply 3 to itself. 3 times to itself. First, we multiply this first two matrix. We multiply this first column, or first row, to this first column. First row, second column for this one. Second row to first column. Second row to second column. For this a squared, we get a value of 1, negative 2, 6, negative 3. And for the last, to get a cube, this is the a squared. To get the last, or to get a cube, we multiply again the value of a. Just the same in the process, we multiply this first row to first column. We multiply first row to second column. We multiply second row to first column. We multiply second row to second column for this one. For the a cube, we get a value of negative 4, negative 1, 3, negative 6. That is the repeatedly matrix. These are the topics in multiplication of matrix.